right, so now what we have here is the frustum, all right, whose the base is 46 centimeter in diameter, and the smaller, the cross section circular part where the other part was cut off has also a diameter of 14 centimeter. Then from the base to where it was cut from, we have the height of 20 centimeter. So we have been asked to calculate the volume for this frustum. All right, so now we have something like this. So this is our base, which had 42 centimeter diameter, and from this base all the way to where it was cut from, we have another circular part with the diameter is 14. Then our height from this base to where it was cut from is 20 centimeter. So now we don't know the height from where it was cut from, okay, where it was cut from all the way. So what we have here is like this, yeah. Then from this where it was cut from to the apex, right, to the apex part, like this, is it like that? Okay, we don't know that height, so we call it x. Okay, so we need to find this smaller height, okay, so that now we know the bigger height, okay, the height that's from the base all the way to that. Okay, why? Because our formula for this volume of frustum has the formula of, say, V is equal to 1/3 times pi times the bigger radius squared times the bigger height, minus 1/3 or times the pi times the smaller radius squared times the smaller height. All right, so now that we know the formula, what we need to now know is what is our bigger radius. So our bigger radius, it is half 42. Half of 42 is what? 21, right? 21. So the radius for the smaller one is 21. What about the radius for the, the radius for the bigger one is 21. The radius for the smaller one would be, half of 14 is what? 7. So we have 7 centimeter, right? Then we know the height. We know the height from this point to that, okay? Because now what we have is, we have 20. If we add 20 this plus that x, we are having the 20 plus x for that height. So for the bigger height, we have 20 plus the unknown height, okay, where our unknown height is small x. So we need to know that x, then we'll be good to go, because that's what is missing. It is that height. So now how do we find that height? So we're going to use proportion. How? We are going to say this height, which is x, over its radius, which is 7, is equal to the height for the larger cone, which is 20 plus x, over the radius, which is 21. Then after that, we close multiply. So now we have 21x is equal to 7, open bracket, 2x plus x, all right? Then we have 21x is equal to 7 times 20, we have 140. Plus 7 times x, we have 7x. Then we group the like terms. So we have 21x minus 7x is equal to 140. Then 21x minus 7x, we have what? 14x. So 14x is equal to 140. Then divide both sides by 14. Now that makes our x is equal to 10, because there are 10 or 14s in 140, right? So now we know the value of x to be 10. So that makes this height from this point to that to be 10. So we have 10 centimeter. So the height for the larger cone, it is the total of 30, because now we have 20 plus 10, we get 30. So we have 30 centimeter. Then here we have 10 centimeter. Now that our data is full, we can now use the formula. So we're going to say V is equal to 1/3 times pi times our radius for the larger one is 21 squared, okay, multiplied by the height for the larger cone, which is 30, right? Then we say minus, Okay, I need more space. Okay, so no need of bracket. Anyway. Then I have 1 over 3 times pi times the radius for the smaller one is 7. So 7 squared times the height, which is 10. So, let me create space. Come on, move. So now my v, let me write this. My v is equal to 1 over 3 times pi times 21 squared times 30 minus 1/3 times pi times 7 squared times 10. And we can just punch the whole that on our calculator. All right, so what you're going to have is 1 over 3 times pi, which is shift there, pi times 21 squared times, we have 30, okay? There is a minus, right? Then we have 1/3, right, times pi, right, times 7 squared times 10. And our final answer will be that we have 13,341.2968. 13,341.2968. Leaving our answer in 1 deep, we have 13,341.3. So our answer will be 13,341.3. All right, watt cubic centimeter in how many dp? In 1 decimal place. This is our answer. That's how you solve such a question. Let's check out the next video.